Hello, everybody. Thanks so much for coming to the conference and for selecting this talk. I really appreciate you being here. My name is Michael Lynn, and I'm a developer advocate with MongoDB. And today, I'm going to talk a little bit about MongoDB, about Realm, and where these two things come together. Really quickly, I'll mention that I cover these topics and many more on the MongoDB podcast. You might be interested in learning more about other aspects of MongoDB. You can check that out at any of your favorite podcast networks, Apple, Google, Spotify. Be sure to subscribe. I also hang out at the community. And if you have questions after, if you didn't get to answer or ask them during the presentation or directly after, please visit me in the community at community.mongodb.com, and I'd be happy to answer any questions you have there. Today, I'm going to talk about MongoDB. I'll be delivering a brief introduction to MongoDB. If you're familiar with MongoDB already, it's going to be a bit of a review. If you're not, it'll be an introduction. I'll talk about Realm, RealmDB, and Realm Sync. These are amazing products that help you create apps that don't suck. And then I'll explain where these worlds collide, MongoDB and Realm, and how they come together and how the Swift development community can benefit. You know, when I was putting this talk together, I was reminded of a television show from the 2015 timeframe. It was a great science fiction TV show where an alien crashes to Earth and finds himself in this star-crossed romance with a human. And it really reminds me of the relationship between MongoDB. So bear with me as I go through this. On one side of the tracks, so to speak, you have this server-side developer, and he's developing applications using server-side technologies, and he enjoys flexibility as it relates to his data persistence layer, and he works in objects and enjoys being able to leverage JSON, just native JSON objects in his code, and working with triggers and data reactivity. He enjoys all these things as he's developing his applications, and especially enjoys an idiomatic approach to data persistence in his code. That means when he's working in Python, he can use Pythonic expressions to manipulate the data rather than having to learn some new syntax or language. And he also enjoys a seamless synchronization layer. So synchronizing data between servers automatically, providing really great resilience and high availability in his applications. So he naturally chooses MongoDB for that. And as a server-side developer, he enjoys using MongoDB. On the other side of the tracks, we have another developer. Now she focuses on mobile applications. She also enjoys flexibility and working in objects and JSON, reactivity in the database, and an idiomatic approach. So using codables and objects directly in her Swift code when she's working in iOS, and seamless data synchronization between devices. So for her data persistence layer, she chooses Realm. But see, this is where the drama ensues. Will they ever be able to come together and work collaboratively where MongoDB and Realm are in the same application stack? They're certainly star-crossed. So she says, damn it, Roman. Roman is the other character's name. MongoDB is just not available for mobile. And Realm simply doesn't work in the server space. Can't you just use Realm? And of course, Emery, he says to Emery, but baby, Realm is not available for server applications, and there's no MongoDB driver for Swift. I guess we're just star-crossed. So that's all in the past, and that's over. So today we've got MongoDB and Realm, and they're coming together and available in the Swift space. And as a Swift developer, you can certainly enjoy the benefits of both of these great technologies, and that's what I'm going to talk about today. Let's focus a little bit on MongoDB, and we'll get into why developers enjoy using MongoDB. MongoDB uses a document data model and has, as part of its architecture, MQL, where you may be used to SQL. We think it's simply the fastest way to innovate. See, relational technologies in SQL was developed many, many years, 50 years ago, And as a part of that architecture, they designed it so that it would maximize efficiency on data storage and minimize the amount of storage you're using. Today, that's not such a big concern, but what is a big concern is your time as a developer. So any time that you're spending on lack of flexibility in your code, that's valuable time that increases the total cost of developing an application. The second reason is that MongoDB presents a multi-cloud global database option. And I'm going to show you how in literally minutes you can deploy a cluster of highly available, highly scalable servers in literally minutes. And lastly, it is truly a data platform. So it's a unified experience for managing and manipulating your data using a consistent API across platforms. So let's go a little bit deeper into the data model. If you're coming to this talk from a relational background, you'll be very used to the ERD on the left, where you see the table design. That's common practice. That's how you design a data layout or a schema in relational technologies. You separate the data by the type of data that you have. And on the right side, we've got a document. It looks like a JSON document. And as you know, JSON is key value pairs. You've got keys that are always strings, and you've got values that can be quite flexible and even quite complex in their nature. In this example, we are showing the value of embedding data, where you might have to link it in the relational world. So we have this kind of mantra when we're looking at document data design or schema design in MongoDB. We say that data that will be accessed together should be stored together. And that's possible through the use of embedding. So we're embedding location address right in the very same document rather than placing it in another object that we have to link to. That provides a level of efficiency that is difficult to achieve in the relational world. These objects that look like JSON, they naturally map to objects in your code. So when you're manipulating your data in code, you're using standard native objects, and it's a very natural approach. MongoDB also supports the concept of polymorphism. So where you have, in the relational world, you have tables and rows and columns. You simply can't have one column with a different number of, or one row with a different number of columns than another. In MongoDB, that's how you can do it. It supports polymorphism. You can have a different number of field values, key value pairs in one document, right alongside another one that has a different set. That's really powerful because you can be flexible in designing how you lay out your data. MongoDB supports strong typing. So there's over 20 different types that are supported natively in MongoDB. And you might be saying, well, I know JSON, and there's only a couple of types that are supported. We actually don't write the data to MongoDB in JSON. We leverage something called BSON. And BSON is a binary encoded form of JSON. And really all we're doing there is, for each field, we're storing a couple of extra bytes at the end of that field to indicate what the type of data is. And that enables us to let you, as the developer, not have to worry about the types. You just store the data type, and when you read it back from disk, I'll give you an example. So if we didn't have this and we were just using JSON, straight JSON, when you read that data from disk, if it were a date, you would not have a date type. You would have to have, in JSON, there's no specific date type. You would have to convert it from some string and determine if the year is at the front or the back, that type of thing. With MongoDB, you have a true date type, and you can write it out to disk in that way. And I'm going to use this term idiomatic. I've used it already. What it means is you use the standard language and syntax to manipulate the data rather than having to formulate these long SQL strings and send that to some interpreter. It's all natural to you. The model constructs in the document data model we've talked about them already. Fields, these are attributes, and we have sub-document capabilities, and then arrays, and these are interchangeable. So you can have arrays of sub-documents and sub-documents with additional arrays, and it can get quite rich in the way that you express the data and the relationships between collections of data. With MongoDB, we support the concept of a driver. So if you're using C, you're going to use the C driver. If you're using PHP, you're going to use a PHP driver. And there are drivers for pretty much every language and framework that you could possibly want to work with. And notice down at the bottom there, we've got a driver for C. I'm going to talk about that shortly. When you deploy your application with MongoDB in your stack, it's going to look something like this. And if you're using MongoDB Atlas, you'll have your application at the top using a driver. It's going to connect to your MongoDB database that is living in the cloud in one of the top 3 cloud providers. So we have support for Google Cloud, AWS, and Azure. And behind those, we're deploying instances of servers using our application called MongoDB Atlas. So to do this, you're going to log into MongoDB Atlas, select the cloud provider of your choice, and deploy the clusters of MongoDB to the size that you want. And I'll walk you through exactly what that looks like. If you're deploying a mobile application, this is what your architecture might look like. On the front end, which is over on the left there, you've got a mobile app. You're going to use the Realm database. Haven't talked too much about that yet, but I will. And then in order to keep that device data resilient, in case, I don't know, maybe the subscriber or the application user wipes their device, you want to synchronize that off of the device, and you're going to do that using Realm Data Sync. And that's going to sync to a backend MongoDB database in Atlas. Pardon me. So let's dive a little bit deeper into Realm DB and Realm Sync, because this is a part of our architecture today. I don't need to tell you, your mobile developers most likely, there are 5 billion devices out there today, probably even more. It's crazy the number of devices out on the internet connected. Half of those are smartphones. And in the new world, I mean, you and I know this, app usage is just the norm. If I'm interacting with a new business, I'm concerned as to whether or not they have an app that I can do business with them. It's just the norm. People are coming to expect it. Beside that, 70% of workers are no longer sitting at desks. They're mobile. And I would be willing to bet that 70 is a conservative number given the pandemic. So I don't need to tell you the importance of developing a mobile app. The issue comes in when application developers develop apps that are not phenomenal. They need to be phenomenal in order for people to continue to use them and enjoy using them. Some of the reasons that apps suck today is, one, there's no data sync. Like, you're not synchronizing data off of the device, and consequently, users will lose their preferences, and that's just not a really good experience. The second reason is there's no real-time update. I've experienced this personally. There was a commuter app that reported the timeliness of trains, and believe it or not, they didn't have real-time updates, and consequently, late trains were not reported as late trains, early trains were not reported as early, and it was a really frustrating experience. And the last reason is that for some reason, apps are not developed with offline in mind. You know, the nature of a connected world is that there are disconnections, and not every app is going to have 100% online. So you need to be prepared, and we're going to talk about how you do that. I probably won't go too deep into this. This is just some reviews on some apps that suck in the same way that we just described. All of this is avoidable and relatively easily. And if you look at the other side of the coin, why are they really great? Like, here are just a few apps that are phenomenal that I use on a regular basis. The average rating is like 4 stars, which is crazy. And the standards, the apps that were shown here, they all have an offline capability. They were developed with offline first in mind, regardless of the strength or the resiliency of the connection that they have. They are reactive. There's immediate updates to UI as data changes. They're resilient, they're performant and stable, and they're real-time and collaborative. And lastly, they are a seamless experience. When a person moves between devices, their preferences just follow them. So a challenge here is that some application developers will think, I can do this. I can develop an app that has all of those things, and I'm going to do it myself. Well, the do-it-yourself approach, it can be conceiving. I developed an app for a painting contractor who had 50 plus paint trucks out there, painting contractors out there rolling trucks. And I thought to myself, well, I just need to wait for an application request from the UI and send that back to the server. And eventually I'll get data back. I'll receive the data and then I'll update the UI. It's pretty simple. How hard could this be? Well, what it turned out to be was that I constantly needed to be checking whether the app was online and implementing error handling for offline scenarios and implementing a retry mechanism that was very complex. And then once my request was sent, is my app still online? Has the request timed out? Are there server errors that I have to deal with? And if I do get a response back, then is it correctly formatted? Did I get all of the data? Is it, are there write conflicts? Are there expected errors? Have I handled every exception type? And what this turned out to be was an extremely complex use case for me to code myself. And unfortunately, that was a bad experience for me. But today, I have a better tool set at hand, and this is what that looks like. So on the iOS app, I leverage Realm, and the application writes to that Realm database locally on the iOS device, and then I leverage MongoDB Realm Sync to synchronize that with a backend. Now you could try this yourself, and if you want to do the same job that Realm has done, you're going to need to hire about 250 software engineers, or you could just take more time with the resources that you have, spend about a year developing the same type of capabilities that Realm delivers, or you could select to use Realm. And Realm, by the way, is free on the device. If you're using Realm DB locally on the iOS, it's an open source app. You can download it and implement it. So there's a couple of different products that I'm going to talk about and I'm going to show you. We're talking about Realm DB, which is on the iOS device. Then we're going to go into the synchronization capability, which is going to keep your data online. And then on the other side, there's the legacy not legacy, but it's MongoDB Atlas, which is on the back end, and that's where your data goes. So think of it kind of three layers. There's the front end, the sync layer, and the back end. And I'm going to log into the back end, and I'm going to show you what that looks like, as well as show you what an application looks like. So we talked about the fact that it's offline first, and there's Realm Sync. I want to be cognizant of time, so I can show you some of this cool stuff. MongoDB Atlas, you may not be familiar with it. It's free to use. You can log into MongoDB Atlas going to cloud.mongodb.com and begin to spin up a cluster of MongoDB servers in literally about 7 minutes. It's super easy to do. You can deploy a free instance. We name the instances by tier. Each tier has a different set of resources associated with it. The M0 tier is free, and it will be free forever. You don't have to pull a credit card out to build it. There's no expiration time. You can use it. I wouldn't recommend it for a production app, but you can continue to use it forever. It's got most of the same capabilities that the larger end instances have. There's also, and I want to point this out too, there's also Realm services in Atlas. So we'll cover that. We'll go into a little bit more detail there. This is what it looks like when you're leveraging MongoDB Atlas on the back end. You've got your client syncing with Realm server. I kind of covered a little bit of this. It supports both reads and writes from the client, keeping everything in sync on the front end so that you have a seamless updating UI. I'm going to show you how to implement notification tokens so that changes that happen on the back end are automatically flowing through to your front end iOS app. I'll show you what that looks like. Don't take my word for it. Here's some just the obligatory NASCAR slide where you've got some of these great customers just really enjoying the power and flexibility of Realm. Who wants to take a look at this? Do we have any questions before we get into what this looks like? I'm going to pull up. I think I'll first go into Xcode, and we're going to take a look at what a Realm app looks like, and then I'm going to show you the backend. So we'll go front to back, and I'm going to lose a little bit of visibility. I hope I can keep track of questions as they come up. If I don't, I will at some point get to your questions. So what you're looking at here is this is a Realm app. It's fairly simple. If you want to do what I'm doing right now, you can use clone, and the GitHub address is let's sgithub.com. Merlin is my GitHub ID. And that's MRLYNN, LYNN. And the repository is called Realm Tutorial. And if you clone that, there's going to be a number of branches. Just select the main branch. Okay, so just select that, clone it, and you're going to begin right where I'm at now. So I'm not going to actually clone it again because it'll take a little bit of time. I'm just going to show you what it's like to implement Realm, and then I'll log into the backend. I'm setting a breakpoint here, and let's take a look at what this app looks like running before we actually dive into the code. So here I've already started it. I'm gonna log out. The initial view controller is fairly straightforward and simple. You'll see this pattern. Let's log in with m@m.com, and I'll sign in. And it's going to present me with some tasks. Now, these are just tasks that I want to keep track of, and tasks can have state. So if I click on one, I can start progress on a task. I can slide to delete. Okay, so we'll have 2 tasks remaining. I can add a new task, and this will be the 3rd task. Finish this talk on time. And so we've got 3 tasks in there now. Let's put that one in progress. And this task I finished, so that'll be complete. So these are being saved to the iOS device locally. And as changes are made in this app, they're being synchronized to the backend using Realm Sync. So let's go ahead and take a look at this app from the very beginning. Now, in Scene Delegate, this is the first thing that loads. We are setting an app ID. So this is just a struct with constants in it. And we're going to send that to a Realm. I should say, I completely skipped the fact that this is a third-party library. You're going to, once you clone it, it's going to look something like this. There's going to be a pod file. Obviously, we're using Cocoa Pods. You're going to want to do a pod install. We'll take a quick look at the pod file to see what that looks like. We're setting the platform, and we are using Realm Swift. I'm leveraging a beta version, so kind of on a tight wire here. We'll see if everything works correctly. So Realm Swift version 10.0.0 beta 3. I think we're up to beta 5, but this is as far as I've tested so far. So once I do a pod install, I get my workspace. You're going to want to open that workspace, and that will be where we are here. The first thing that loads is our scene delegate. That's where we're going to specify this. Think of it sort of like an API key. We call it an app ID, and this is going to identify our app to the Atlas backend, and this is how we implement Realm Sync. The next thing we're doing is we're going to load the initial view controller, which is welcome view controller. This is a fairly simple project. All I've done really is deleted the main storyboard. We're not using storyboards. We're building them by hand. And so then once we load the welcome view controller, let's go up to the top here. We're pulling in our Realm Swift library. And check. Okay, so we'll pull in the Realm Swift library, and this is where we're going to define our layout, right? If we look at the app, again, see that we're building an email and a password, a sign-on button, and a sign-up button. We're creating a getter for our email and password, and then our view did load is going to do some aesthetics to make sure that everything looks nice and neat, regardless of the direction that the app is facing. Everything looks nice and tight there. We're going to create a set loading. So we have a loading indicator, and then we've got our sign up and sign in. Now, you'll note that we're using an instance of that app, right? So if we jump back to our scene delegate, that we're creating this, and if I look at this app method, that is coming from the Realm database. So you'll see these aliases set up for RLM. Everything behind the scenes is called RLM. So we're in the Realm app here, and this is what's happening when we log in. So back to our view controller. So sign up will create an email password auth with a register email. And similarly with our sign in, fairly straightforward, just passing credentials to the backend and logging in. And then we create an instance of Realm. Okay, now we have Realm in our code, and we can begin to store, based on what happens in the application using our Realm file. Once we successfully instantiate the welcome view controller and we've signed in or signed up, we're going to transfer control to our tasks view controller and passing the Realm. So we're going to pass that Realm in, and we'll go into tasks view controller. And here we're initializing the Realm, setting some things up. One of the things that we're setting up, which is really key here, is a notification token. So if I look at the source of this, this is part of Realm. Oh, here. This is part of Realm. And it enables us to create an observer. This is how we're able to update when the backend changes or another device updates data on our backend. This is how those changes are going to notify the front end. So we create this notification token, and we'll be using that, and we'll check on the status of the changes as they come through. There's an enum associated with the type of change. So if there's an update, we're going to make sure we process that and update the table view accordingly. And once we're doing our view did load, we're going to create a logout button once we're logged in. And I've implemented a refresh. You should not need this refresh. You shouldn't need a pull to refresh because the changes should just flow through. But it's kind of a just in case thing. It's a demo safety net, I'll call it. Okay, so standard table UI, table view controller stuff. You've got to have a cell for row at. If you're new to using table view, you'll just need to have these stubbed out functions. So you'll have cell for row at, which will help us determine what's going to be the contents of each and every cell. This function is going to be called for every cell that is number of cells. So for every one of these number of rows in selection, we're going to take the number of tasks, and we're going to iterate through this for cell for row at, and we're going to pluck off a task from our task database from Realm, and that will provide the basis of the contents for each cell. Then we'll dequeue a reusable cell, and we'll set the style, we'll set the text label to the task name, and so on. Fairly straightforward approach to creating a table UI, and the only difference is obviously that we're leveraging a Realm database locally on the device. So as changes take place, the local database is modified. So what happens when we do modify data? We'll go through this again. Sign in. And we've got three. Let's complete this one or open it. We'll leave that one open. And we've got 3 tasks with 3 different statuses. From here, what I'd like to do is introduce the backend and show you what the synced side looks like, the database sync side. So we're at 10:30. I think we're doing good on time. Here, I'm going to go into MongoDB Atlas. So MongoDB Atlas is, I've mentioned this before, it's a web-based application that MongoDB wrote. The makers of the database created this to help you deploy and manage your MongoDB instances. Now, there are 3 sections. I'm going to go right into the cluster section because I need somewhere to store my data. So I'm going to create a cluster, of database servers. So if I look at my clusters, I've only got 1 in this instance, but I can create multiple. I think it's helpful if I look at what it's like to create a brand new cluster. So I'll click Create New Cluster. This is our creation wizard. The first questions it's asking you is about global cluster configuration. If you have a globally deployed application, you're going to want to position your database clusters adjacent to those users so that you get really great performance. Second, you can select cloud provider. Notice when I change the cloud provider, the data centers available to me change. That's because obviously each cloud provider has a different set of data centers. I'm in Philadelphia, so I'm going to select North Virginia. And then I select the cluster tier. Now, I've already deployed 1 free sandbox instance in this project. You can deploy 1 free in each project. If you need more than 1, you can deploy multiple projects. From there, you're going to increase the size based on the requirements of your application. And there's some math you can do about the read-write profile to determine how much memory and how much disk you're going to need. One really cool feature is auto scale. So MongoDB Atlas, we don't want you to pay anything more than you have to. So if your guess about the tier size is not correct, and maybe you undersized it, for example, you deployed an M2 or an M10, and you want to make sure that your users don't experience bad performance, you can turn on auto scale and select the lowest tier size can be an M10, and I'm in an M30 now, so you can't go below that, but and then you can select a higher size. So in the worst case scenario, maybe I want to set it at an M50. So if the read-write profile is maxing out CPU and memory, it's going to automatically launch up to an M50. And it'll do it in stages. It'll go to the M40 first, and if it continues to experience challenges, it'll roll to the M50. And I want to be checking on the chat. Okay. So this is what it's like to deploy a cluster. If I change the cluster name and then I hit create cluster, what we're going to get is something that looks like this. Right, here's your cluster. It's going to give you a quick view of what's happening in terms of reads and writes. You can get some more detailed metrics by clicking into the metrics panel. This will show you very detailed statistics about what's happening. But what I want to show you is I'll continue the previous demo about Realm, and I want to go into the collections. This cluster serves up several databases, and I want to see the collections that are in those databases. So I'll click on the collections tab. Here we have a list of the databases on the left. I've got my cats database, got to have a cats database. And then I've got my task tracker with 3 collections inside that database. The one that I'm concerned with right now is those tasks that I talked about. And there are those 3 tasks that we represented in the application. If we pull that up again. So you can see the statuses are exactly the same. If I were to delete one of these from the backend, I'm going to have to be quick and switch over because it does update fast. If I delete my project, this task, right, because it's done, I want to delete it. Maybe I've got an API that it's running a node app on the other end or something, a server app. I'm gonna delete that, and it's going to automatically update. I didn't hit refresh. I didn't do anything. That's because of that notification system. Realm is synchronizing between the front end and the back end. And similarly, if I add another app or another task here, when I come back here, if I refresh, let's see if I can beat it. Nope. My another task is already written. So it's pretty quick in terms of how fast it synchronizes. So that is what it looks like on the back end. We've written a very basic app. We've implemented Realm, and I've demonstrated how the front end is able to synchronize with the back end. Now, there are a whole host of other capabilities built right into MongoDB Atlas. You'll notice this tab here, Realm. This is where I went in order to create the Realm app ID that I talked about earlier. So if I look at the code again, in my scene delegate, this app ID is correlating to one of these Realm applications that I created inside MongoDB Atlas. This is how we configure the services for the backend. Here's the tutorial phase 1 app. I think that's it. Yep, tutorial phase 1. And you copy your app ID and paste it in here. And this is a backend application services screen for this tutorial app. And here's where we specify the things like what kind of rule sets do we have in place for data access from the front end. Obviously, this is a very simple app, so I don't have anything really major set up. It's just the default set of permissions. I can specify the synchronization criteria. I'm specifying that this app that I created here, this one, is linked to my cluster 0, and I'm choosing a partition key to indicate that the realm that this is modifying. So there's a correlation between the partition and the realm and the Atlas cluster database. And I've got this service running. So when updates come in from my iOS application, this synchronization service is running and it's listening for those changes and it's synchronizing them to an online Realm file inside the Atlas infrastructure. That's how that's all done. But if you're interested, there are a whole host of other things that you can do with Realm on the back end. You can implement triggers for data reactivity. So if you get a new user, if a new user registers, you can run another function. And if we take a look at that function, create new user document, this will run every time a new user logs in. And what this is doing is it's inserting a record into a cluster. So yeah, this is very flexible, very powerful. This function is ES6. So currently in the Realm backend, you can write fully functional ES6 JavaScript applications. We provide you with a context variable, which gives you access to services. One of those services that you get for free is MongoDB Atlas. So you can create a connection to the cluster, create a connection to your database, and issue MongoDB commands using JavaScript syntax. And that's what we're doing there. There's also MongoDB charts built into MongoDB Atlas. I don't have anything created here, but this is a great way to visualize the data that you're storing in your database. It's super easy to use, takes a couple of minutes to get up and running. There's even sample data that you can deploy that will automatically, with MongoDB charts, you'll automatically be able to visualize that and see exactly how it works. So where are we? We've created an app. We've shown the back end of that app. And this is my list of things that I wanted to get done. Spin up a cluster. Yep. Did all of those things. Well, here I wanted to talk briefly about how these worlds collide. So things are coming together for the Realm and the MongoDB world, and it's coming together with Swift in mind. So there's a great union between MongoDB and Realm. And we've announced availability of a MongoDB Swift driver for the server side. So the server side Swift driver for MongoDB is available today. It supports both asynchronous as well as synchronous use cases. Asynchronous would be great for like a web app. For web apps, or sync is really good for an interactive workload, such as a command line utility. I actually wrote a blog article off of MongoDB, developer.mongodb.com, that talks about how exactly to use the server-side Swift driver to develop a command line utility that leverages MongoDB. I talked about BSON earlier. So in the same way that all of the other drivers support a binary encoded version of JSON, Swift is doing that too. We leverage Swift's codable types to do that. So enabling custom types directly with MongoDB collections. It supports triggers through MongoDB change streams. And this allows you to react to real-time changes in the data. And like I said, maybe if a user logs in, you want to enrich the data associated with that user. That's a great way to implement that type of enrichment capability. MongoDB has a phenomenal aggregation framework. It sits right next to the MongoDB query language, and it allows you to do things like analytics and grouping, summing, all of the same things that you might do with SQL. Here's an example. You stack these, and they're sort of like a pipeline. So I'm looking at my orders database, my orders collection, and I'm matching on statuses of orders that have a complete, and then grouping them and totaling the sum of amount. So that's the aggregation framework, fully supported by the MongoDB Swift driver. Supports connection pooling, so for dramatic improvements in performance. It makes fewer requests for connections and leverages those in pools. Today, it supports use on the Linux platform, Ubuntu, and Mac OS. So you can use your Swift skills as an iOS developer, use those over on the server side on Mac OS and Linux. For more information, here's some links. Here's the Swift driver. It's GitHub under the MongoDB. And then there's an official announcement. And then I wanted to take you through what that driver looks like. So let's go over to VS Code here. And what I've done is I've created a very simple Swift package. So if you're familiar with Swift Package Manager, it's very simple to do Swift package init, and then change the Swift package file, the package.swift file, to pull in the MongoDB Swift driver. You do that by referencing this URL. We're currently at 102 or 103, but I've got 101 in this example. And then specify your dependencies and your targets. So we're going to use MongoDB Swift sync in this example. And then, of course, you create your main.swift with the code. So here, what I'm doing is I'm pulling the Swift synchronous driver in. I'm creating a connection string. This is how I connect to MongoDB. And this is a cluster address that I get over here from MongoDB Atlas. I get that by clicking connect and showing connect your application, and I copy that string. Okay, that's going to give me the connection URI for my application, and it looks something like this. Now, I don't want to give you all my password, so I'm using an environment variable. Swift supports that through processinfo.process. That's why I'm using Foundation. Once I pass the password over to this, it'll give me a handle to the database using client. Then I'm using codables to create objects for my data that I'm manipulating in my program. This is what that task object looks like. It's a codable that gets swapped between JSON and BSON. Then I create an enum for the various task statuses, and I leverage that client handle to create a handle to the database. And there are a couple collections in there. I'm not really using this one, the user collection, but I am looking at the task collection, and I'm just going to do, I could insert some more tasks if I wanted to, but I'm just looking at the documents that are in a find. So I'm going to find all documents. And then I'm going to get each one of those for D in documents equal to a find, the output of the find. That gives me a cursor. And yeah, so then I can do a Swift build. I think it's already built. And a Swift run. I'm going to connect to the database and print out. Now, these are some local. They are on a different platform, partition, but here are those three tasks that I created. So I'm pulling those from the backend of MongoDB Atlas. So that is the MongoDB Swift driver. And I just wanted to jump back into my talk. Again, invite you to join me in the community. If you have any questions that we're not able to answer here today, I'd be happy to do that. There's a lot of developers that are logging in and creating new topics and having great discussions. And again, I hope you'll check out the MongoDB podcast, where we've got all sorts of fun stuff happening. Okay, so get my questions umbrella. Okay. Oh my goodness, so we've got a few. You write your own sync. Yeah, thank you, Ellen, for confirming that writing your own sync is a terrible idea. I've experienced that. What are the main differences between Realm and Firebase? I'm not a Firebase person. I really don't have too much experience, but from what I hear, it's an okay technology if you want to leverage that. If you're in the Google ecosystem, I just don't. I can't speak with any authority on what it's like to use Firebase. I can tell you that Realm is cross-platform. You can use Android clients. You can use iOS clients. You can obviously write code cross-platform. I don't know that you can do that with Firebase. The benefit of using Realm over Core Data and CloudKit. Well, I've heard. I haven't done a ton of work in Core Data. I think I attempted one project in Core Data, and I just had a really terrible time. I likened it to performing surgery through a blanket, because you got this additional layer of modifications that you have to do. But I think the design goal for Core Data and CloudKit is the same. I just find the Realm interface, the API, so much easier to use. It's just so much easier to implement than Chordator and CloudKit. The lowest iOS version does Realm support? Oh my, I don't know, but I can find out. I'm pretty sure I've got somebody waiting. What is the lowest version of iOS that Realm supports? See if somebody can jump on that. I'm currently using, I've used 11, I've used 12. Both work well with Realm. I have not tested, recently anyway, Realm on lower levels. Realm's been around since 2015, I want to say, 2014 maybe, quite some time. But I don't know what the latest version support matrix looks like. So I will attempt not to mislead you there, and hopefully somebody will answer me on the back end. That leaves it with just saying thank you. I really appreciate everybody's time today. I appreciate you choosing my talk to listen to. It was great fun delivering it. If you have any additional questions, I'll hang out for a little bit. And if not, I hope to see you at community.mongodb.com. And I hope that you'll give the MongoDB podcast a listen. And if you do listen to it, give us a thumbs up or a like or a positive review. That'd be awesome.